Good afternoon. This afternoon, we are back to the class Physics 102. So quickly move to the last part where we stopped in the last time. And I remember I gave you 2 questions to try. Apart from those who submitted their solution immediately, by now you should be able to, or let me assume you have tried your hands on the questions. So at any time, like I said, if you have any query or something that is not clear, there are people who attend to you at the atmospheric lab upstairs in White House. Just ask for atmospheric lab. So 2 of the staff can tell you the problem is a bit difficult, then my attention can be called, but only on Physics 102. Mind you also, you have the privilege before the test period or exam period. No student is allowed to come. So we'll start with transformation of Coulomb. Coulomb's law. That word transformation means you can look at the same law in a different way, but still mean the same thing. Exercise for you to solve the problem. Then the second expression, flux phi of E, can be equivalent to the closed integral of E dot ds. That is, it is also assumed that you should be familiar with simple integration. And that's why the idea of this mathematics is brought here. And of course, you should know by now that that integration is like the opposite of your differentiation. So for any equation that is in a closed system, we are expressing the region where the effect of the charge is known or covered. So if for some other integral, they can specify the range, that is closed integral from -2 to 4. So, what's long? said there should be a way one could know here.
But I used to see your.
No, I couldn't. I couldn't see it again.
No, that battery showing.
Okay, Otilo. Okay.
I just said, okay.
No problem.
Never seen it before.
The signal looks good. I don't know. This is not the signal.
No. The signal, but it's using a long one. The echo. Yeah, I'm saying it's about this. Just a little bit. Notice that was not shape or connect. Okay, we here now. This.
Sorry, it's because of the electricity problem. So I think we are now on. So I also want to assume you can hear me clearly. Yes, you understood that it's not yet stable, it will soon be stable. Now we can go ahead. So I'll explain this expression. The next slide can now look like explanation on the general expression phi of E equals the closed integral of E dot ds. Therefore, in any hypothetical surface, the electric flux represented with phi for the surface and the net charge Q enclosed is given as phi E equals the closed integral of that electric field dot ds. So if I give you a value for the electric field, just integrate over that range, maybe between 2 and 4, 5 and 7. So S now represents the surface area on which the field region is established. So take note of that. We want to quickly mention uses of Gauss law. Gauss law can be used to predict that an excess charge on an isolated conductor is in equilibrium. And try to understand what we mean by excess charge, then the unisolated conductor. Apart from the single charge, when you have two or more charges, then the red operating, you need to be checked again. That is linked with another one. Then you look at the entire outer surface and see how the charges move. That's what that statement means. Point number two, if an electrostatic equilibrium is zero everywhere inside the conductor, it must be zero for every point on the Gaussian surface. And this is another important point for you to note. Each of these points is an opportunity for you to get it correctly, because it's a simple information and direct scientific language about static electricity. So take note of that. The flux phi for this surface must be zero. Once those two conditions are met, it means the flux for this surface must be zero. Then there must be no net charge inside the Gaussian surface. So now see the word inside. The big thing that the different quantity, negative to negative or positive to positive. So they will repel each other. But once the attraction occurs between charges, it simply means one is inside and the other can be outside. The next point, the flux of the electric field is very important when it comes to the ratio between the distance between two charges and the number of charges involved. So take note of that point. So we go to the next slide. The electric field, E, outside any spherical symmetrical distribution of charge, is directed radially and has a magnitude E equals 1/4 pi epsilon naught Q over R squared. Of course, we have separated 1/4 pi epsilon naught because in our past equation is equivalent to K. So that when you come across another equation that states E equals KQ over R squared, it still means the same thing, because the quantity K is equivalent to 1/4 pi epsilon naught. So Q now represents your total charge. You take note of that. But the electric field E inside a uniform sphere of charge directed radially has a magnitude E equals lambda over 2 pi epsilon naught R. Now you have to be mindful of the difference between this equation. So you now see that this is the electric field inside a uniform sphere. And number two condition, that the charge is directed radially. That is, the radius R will be the same at any point from the center of the sphere. In fact, that's why you call it uniform sphere. That's why students can be easily deceived. If I have to draw two different diagrams with different radii, it simply means that this equation will not work. you have to go back to the other equation where we can make the difference between the two charges and the difference in the radius. Well, in this case, once it's a uniform sphere, you make use of this equation. And so, like I told you earlier, you can be tested on the equation alone. So if I make lambda the subject of the expression here, then the flux will directly multiply your 2 pi epsilon naught r. The third condition, you now see the reason why E naught must be given. Because sometimes your E naught may not be K substitute. That is, E naught here cannot be substituted with E naught 1 over 2 pi epsilon, 4 pi epsilon naught r square. So you must identify the difference. Take note that each equation can be identified with the definition of each term. And so, like I said, as a scientist, you should love to see more equation. In fact, the more the equation, the happier you should become. Thus, this next slide gives you the expression for another equation. Because here we are talking about electric field E due to an infinite line of charge. Can you see it's different from uniform sphere? So once the electric field you are looking at in relation to charge is flowing is different, then the equation will definitely change. Why? Because some will consider the perpendicular distance, so we just consider the radius. Once the radius is uniform all over the sphere. But in this case, it's not true. So therefore, the electric field will be different. So the electric field, due to an infinite line of charge, is in a direction perpendicular to the line. And so it has a magnitude E equals 1 over 4 pi epsilon naught QR over RQ. You can see we are choosing small r and capital letter R to make the difference between what we mean by distance and radius. So, by all possible means, master these equations. So, as a scientist or a science student, you don't have anything to do than to sit down and make sure of your time to master all these equations. So the next slide will show you the next expression of electric field. Then someone will wonder as a student, why are we talking about electric field in charges all through? Yes, because the field determines the charges on the body, because it's an attraction. In fact, once you move out of the field, there won't be any influence of the charge. So, which means the major character in this topic is the electric field. Even when you are talking about charges, you are talking about the law, Coulomb's law, and other static laws. For now, just know that electric field is an important factor that plays major roles in the electrostatic phenomenon. So E in this case will now be sigma. That symbol is called sigma over 2 epsilon naught. You notice something is missing here. Can you guess what is missing in this expression compared to the other 2 or 3? Something is missing because the field is linked with the sheet. That is something that has length and breadth. So the issue of radius does not come in. So there's no way we can bring in the radius into the expression. So the more you change the feature or the figure, then the charges on it will change. So whatever change in the figure will affect the radius or distance. Then the next factor that is important is if the shape of the figure changes, then we consider the area of that figure. So take note of that. E now becomes sigma over 2 epsilon naught. So sometimes the past test classes, you must have seen one of your past questions if you are the type that love to go back to past questions. So which of these expressions represent electric field due to an infinite sheet of charge? Now see that the question that will answer you is only this one because it doesn't consider the radius. Now I'm only telling you the secret of the questions. So the next slide shows a figure. And the figure simply is to explain the move of charges. Now there is a body here, which I'm pointing at, indicating the charges and separating it from the lower one. Why? Because the charges are the same. So we have positive charge or we have positive charges below. So the force of attraction will be far away. So they will repel each other. Any attempt to bring it so close, they will drop down to the same point. So which means this body, which you see as a conductor, will not be affected because so the field looks direct. That's why this arrow shows this way. The field will continue until there is an interval between a positive and a negative charge. And this is to hold the same expression E equals sigma over 2 epsilon naught. Very real. Okay. To the next slide. Now, before I go to the next slide, I think I should be able to dictate the code for your submission. Now listen to the first code. RX 7X4. RX 7X4. That's the code for your own attendance and submission. I hope that is taken. RX 7X4. Okay. Good. It is stable now. I love that response. Okay. If the sound is echoing, I don't have answer to that. I don't know.
Maybe it's not from here.
Okay, so maybe it's from your side. You're asking when did the class started? What? Yes. We are following the same timetable, 12 to 1. So, Yarubanas, or what's your name? You're asking for the difference between R and small letter r. I said for R capital, that represents the clear distance, where R small letter will represent the radius. That means we are bringing two bodies together. One has radius, another one has the distance. So you substitute R capital for the distance apart and R for the other radius. Sir, will the slide be released? Yes. For you to be able to get everything correctly, the slide will be given to you. But that does not mean you should not listen to the presentation. So it's important for you to be on once the class is on. You said the attendance form is not working. Are you sure as I dictate again?
Until you have the 3 codes, you cannot submit.
So until you have the 3 code complete, you may not be able to submit now. Just take note as I dictate the code. I'll still bring the second code to your attention. So you are correct. First code is RX7X4, all in capital or uppercase. Yes. Sigma value constant. That will be given to you in the exam. Okay. So we can move back to the class. Yes, back to the slide. We have explained the last expression equals sigma over epsilon naught for electric field. So E being equals to sigma over epsilon naught, this is the next question for you to try as I dictate. The electric field operating within a specific rod is 25.4 coulomb per meter. Calculate the actual charge that is perpendicular to the surface. Actual charge that is perpendicular to the surface. To get that question correctly, use the same equation equals to sigma over epsilon. Now, epsilon naught you know from the past classes. The electric field is given to you, so you can now find the sigma. What do? You cross multiply so that E multiply your epsilon naught directly. And that gives you your answer. And take note of the units, of the sigma. Okay. I want to take you back to that value which I've given to you on sigma. But if you are consistent with us, you can easily know what it means. So epsilon naught will be 8.85 times 10 to the power minus 12 Coulomb square per Newton meter square. So substitute that and use that to multiply the field, electric field given to you within the region. I hope that is taken. The next question relates with the electric field flux, which we call phi E, phi subscript E. Now, in this question, the electric field is to be determined. The electric flux is 17.5 watts per meter square. What is the total electric field over the area of 18.5 meters square? Over the area of 18.5 meters square. Now you can also try that as part of class exercise. Yes, your response will now show whether I should give you the third trial, but by different equation as it was given to you in the earlier classes. Okay, I see your response now. Understood, sir. Okay, thank you, sir. Okay, I want to assume that you are following by your response. What is the value of E naught? There's something like E naught here, but what do you mean epsilon naught? Epsilon naught has given to you earlier as 8.85. Remember, times 10 to the power 12. Okay? The answer you have given to me here is correct. 2.25 times 10 to the power 10. But you didn't put the unit. Unit is important. That's part of what I want to test. Good. Good. For those of you who got it correctly. Somebody is still asking about the topic for today. I don't understand you. Must confess. What you are trying to do is to take you through, because of the structure of the class last meeting, to take you through part of what you have done again. And be sure you get the calculation correctly, because you should be proud of this course when it comes to calculation. It's to be full of calculation. I won't deceive you. But they are purely mathematical physics. So take note of the third question I want to give now, before I round up. But before I dictate that question, I would like you to listen to the next code. Next code 74FCQ. 74FCQ. That is the next code for your submission. Shall we now go to the next question? We have to determine the electric flux over two conducting slides. Determine the electric flux over two conducting slides placed at 30 degrees to each other, placed at 30 degrees to each other, as the field of the flux moves over the area, as the field of the flux moves over the area of 2.5 meters square, area 2.5 meters square, and the electric field is exactly 10.0 coulomb per meter square. So you can actually calculate the phi of E. Remember, one of the expressions given to you to use now is phi of E equals E A cos theta. E representing your electric field, A representing your area, and theta is the angle between the layer of the field. So apply that now, and let's conclude with that. Good. So today is set aside to see your trial and the application of these equations, because they are becoming so many. And I want to be sure you are really getting the calculation correctly. So please, for good of you, I can see your attempt now. You're asking the value that it should be if it is microcoulomb. If the value of the charge is given in microcoulomb, it simply means you multiply or do the conversion by 10 to the power minus 6. Because micro simply means raised to the power minus 6 of the value. For example, if I tell you 4.0 microcoulomb, then you have to do 4.0 times 10 to the power minus 6 before you can substitute the direct answer. So take note of that. Now the last question for today, we go back to that. That is taken from the previous. I've told you the value you have to use now, epsilon naught 8.85 times 10 to the power minus 12. Put that somewhere. And K, which is something as 1 over 4 pi epsilon naught, equals 8.99 times 10 to the power 9. Don't make the mistake of replacing the value of K for epsilon naught. They are not the same. So you see the equation where the value is given. So this slide gives you this question. Okay? The charge flowing in a ton of wire, Q, is given as 14 microcoulomb. That is 14.0 microcoulomb. That taken, if the distance apart is 2.0 meter, 2.0 meter, the distance apart, calculate the electric field on the point charge. Calculate the electric field on the point charge. Now, to help you better, I can give you directly the formula you have to use, which you are already seeing on the screen. So the equation here is E equals Q capital over 4 pi epsilon naught R squared. So a student who may not need to use the multiple factor of 4 pi epsilon naught, just pick the value representing K as given to you earlier and substitute directly, you get the same answer. So you just say E is equal to KQ over R squared. It only requires that this aspect of question, you have to square the distance. That's why R squared is given to you, to mark the difference between the fluxes within two layers. So I'm expecting your trial again within 2 minutes. So we close for the day.
The last code, sir.
Sir?
The last code, sir.
So let me quickly release the last code while you are working on that. The last code is B capital W capital J6Z. I repeat, B W J6Z. All in the uppercase. B W J6Z. So this is the last code for today. Okay. Somebody is saying you can't see the screen. Yeah. Can we go back to number one question? No, you can't go back to that. There's no time for that, my friend. Somebody is asking what shall be the unit of charge again. After how many times? My screen is blank. Please. What can I do? I don't know.
I think contact any friend around.
So you can contact any of your friends around. The attendance page is working now, sir. Okay, good. Someone should write the three codes together. I beg. I don't understand you. You are saying, Jade Parker, attendance is not working. You don't know the answer for you. The form is saying it's not accepting attendance again, sir.
Yes,
Yeah. Okay, wait in the next few minutes to see if that will work. Okay, we are gonna see what your complaint looks like. We are unable to submit attendance, sir. When will the slide be available? Well, that information will pass to you by the Secretary of the course. Good. But you can be sure you will be given most of the slides, if not all. Sir, is our result out? Why are you asking such question here? I think by next week, there will be information about your results. I mean, last semester result, if that is what you want. Okay. No. Okay. So I've just been informed that you can start to submit now. I think the issue has been rectified. So try the code again. If you want me to dictate the three code, the first one given to you is RX7X4. The second one is 74FCQ, sorry. 74FCQ. While the last code is BWJ6Z. BWJ6Z. Try the codes now.
About 80 minutes to submit.
So you still have about 8 minutes to submit. I can see someone's response that it worked for me now. Your attendance link is now intact. Sir, did we perform well? Where?
Yes, sir.
This is not where to ask that question, I beg. Good. Olaye Mary, it's working for me too. Good. Yes. Elizabeth, something. Your coding is correct. The good. So it's working already good. The last question you're asking, Jade Parker. See those who correctly copied while I was dictating. There's no time for that. I think this will be a convenient time to stop here because of another class that start by 1. Thank you for today. God bless. Thank you, sir.
In the wrong way,
And they are they enjoy it. Thank you, sir.
Yes, sir.
Thank you, sir.
Yes, my landlord. One of our family friends, we shall see. So, six was the year those here, my sister, sister Nick, what you have gone on that. So, they had to start to rush about surgery and the child. Only if you have it done, that my wife will follow. I'm sure 3 a.m. no boy, no. They landed on Monday. They performed the surgery. I think she's surgery right now. I think she's surgery now. And then on Monday, I think they are not. And they rush my boss to tell. What do you do? Oh, I've not gotten myself. It's a the grocery office. We want to start that. Mo ti fi dá àwọn tó sì àti ẹni àti ọba owó sáyìn ní ìkẹlẹ fọọmù yà á ṣe ṣe operation dédé ó tún jọ àmà ẹgbẹ ẹ̀kọ́ ó ṣàmú ìgbòho ẹni ṣe bẹ́ẹ̀ this is my process first and not process. Méjèèjì àwọn ọmọ láti around 11 àbí kẹta ní òfin méjì mẹ́sùn. But ní pẹ́tẹ́rù pàmìjọ kí ni ó ti ṣẹlẹ̀ sí ní 2006 on close friend. Maybe I just discovered I was going. I was thinking. Yeah, I was not to keep it. I was just having almost that kind of feeling. Yeah, I know what's up with this. Mo ti pè ní fídíkà gbàdúrà pé gba ó kàn bẹ̀ sí dákọ́ ó kàn. Very moving, very generous. A teaching a feel like just ẹ̀wà ó ti kẹ́dẹ́ dẹ́ fẹ́ máa ta àṣàbà tí wọ́n wọ́n ní tó fẹ́ ẹ̀wà dé má gbàgbà ti gbé wo kíní kan ṣe dé. Hello, hello, people. You see, already, eh? No. Yes? Yeah. And so she went by. And people will call it, but we found out some legal states. Yeah, that's I don't know if you travel. Yes, sir. That's what's up. Yes, sir. Sorry, sir. This is going. My have solutions.
Sorry for that.
Hey, hey, hey. Torí àwọn kan kọ́pì mi, torí àwọn kan kọ́pì. Bẹ́ẹ̀ mo ti sọ fún àṣà. Ẹ gbogbo ọ̀rọ̀ aṣọ aláràbarà wọ̀nyí. Sọ pé tá a bá fẹ́ wọ uniform, ká wọ uniform. Kì í ṣe pé ká wọ kan ìtàn flower. Àwọn kan wọ white and blue, wà á tún sàárín. Àwọn kan á ṣe ìgbésẹ̀ sọ́ọ̀bì kan mi. Gbogbo wọn la máa straighten out pẹ̀lú eléyìí tí pásítọ̀ dẹ̀ ti sọ báyìí. A máa straighten gbogbo wọn yá by the grace of God. Ó dà bẹ́ẹ̀. No, kò yé mi sà. Ṣé àwọn kwaya kan ń kọrin àbí bishop? Okay. No, that is very strong. That is Rara Budo, especially taking That is it. That is it. Gbogbo kí ni wọ́n ṣe? Owó. It's okay. So that he himself will be happy. Kì í ṣe ká máa sọ kankan tó bẹ́ẹ̀ bẹ́ẹ̀. Àwọn èèyàn fẹ́ gbọ́ nǹkan kan, so it's not good at all. Dára. Àmì sà. Thank you very much, sir. Then sir, ọjọ́ Sunday yẹn, àwọn ẹja akọrin tó jẹ́ pé kí ni àwọn màkàmà tún lo program beat díẹ̀ lẹ́kùn bẹ́ẹ̀ yẹn. Yóò tẹ máa worship the choir. Okay. Oh, hey, wà gbọ́. Àwọn àdúrà bá pé pásítọ̀ Tòkunbọ̀ ká look into all those kìíní bẹ́ẹ̀ kò yẹ kó tún ṣe tí kìíní bẹ́ẹ̀. Ó dà. Okay, sir. We'll see what to do, sir. Okay, sir. Yes, sir. Thank you, sir. Yes, sir. The uniform one, I gave it to Mr. Felix. Yes, give me yesterday. Not give them the exact time with the time with 8 to 9. 8 to 9 or 9. And then Monday and Tuesday. There's only one day. That's for chemistry. Okay, that time. Is mistaken. Time will never fail. Time will free. You have to go down on money. So the courses will not other general courses. I'm looking what I'm going to do in our economy. Kì í ṣe nìkan. Even to general course, even chemistry is a large course of thousands of students. Then library. Higher student body làwọn yẹn. Entire student wọ́n náà ní tiwa ní all part students. Just like ṣé sísí months ló change the title ẹ̀ nìyẹn? 6 months ìgbọ́n ló introduce ẹ̀. Ṣé wọ́n ṣe title ẹ̀ nìkan? Nàìjíríà àkọ́kọ́. Ọ̀rọ̀ ayé ìta ti tẹ́lẹ̀ special elective ẹ̀sìn arówó àti tẹ́lẹ̀ oyè wọ́n compose for ẹ̀sìn arówó one ló compose for nígbà yẹn just for 3 days. But this one is compulsory for us. If you count, if you add up to 68 compulsory. Only wait. That's a serious topic. Like, let me see. Like, yeah, they go 8 to 9. 8 to 9 on Wednesday. It's okay. But, availability àwọn ọmọ wòye ní ọjà courses. Ṣé master wo ni university fees? First, what's the university timetable? Yẹ kó máa jẹ́ káàdì tẹ́ bá fi sí ìpínlẹ̀ central timetable. Wọ́n ní departmental timetable wọn fi síbẹ̀ wọ́n á lè pé kò ní wọ́n mọ̀ lórí fiscal. So then, nínú central timetable láti pé ọ̀pẹ̀lẹ̀ wà. So ìyá bí táìpì wà. When is the 8 to 9? The chemistry. We are in 7 o'clock. 7 o'clock now. We can't be seen now. So I think when you are much more labor, you can collect from the house. So my paper is have CBT, what's that? And I'm supposed to have to go out for the day. No problem, sir. Is it a PTS? No, they zero. Habitually, je t'ai laissé dans ce qui authentic bien here. But we can send it to you. C'est le corps, c'est tout. Che sente sui sistemi di interazione dove c'è qualche so you forward it to me. Okay, what's that? I'm working that I'm very. Incorporate. Sorry. Okay, what's your expectation? Try to open it. People need they search. It's like try to search for it. It's not something. You know, we are thinking not okay. You know, this is just for Monday. You know. BGST 112. It's not here on Monday. It's to the night. Really was okay. The front. Thank you, Taylor. No, Oscar. Thank you, Taylor. No, 8 to 9. Precisely. So once the week, yeah, able to cover more from 1 hour. And it's almost like 2 hours of physical classes. That because you don't have distraction. And everything is so if you then come here and then how will the student how will the student come? Yeah, we okay. No. This is the student interface. This is what you have. It's like a course for it. Yes. Give me your email. So anybody, any lecturer who is coming, there's a daily attendance code. And who's coming to teach. So our sort of the system will send it to me at the level, then that the first code should be given an opportunity to the lecturer. We need the students to update. The second code will be okay. How will be communicating with the students? No, how will they cope with the how use hello, sir. Hello, sir. Yes, sir. I'll call you. You can just give me a few documents, please. It's short. I'll call you back. Hello, sir. Hello. So that's the relationship on the platform. For now, until we was as coordinator now, we must reach out to all the because I will send the notice to all the various faculties. People deans, okay, and all those things. First lecture, via the president, and hello, sir. And please, I'm just going to call please. Sorry. I'll call you back. Yes. So once about said, look at they should have the name, is there. Many of them might even have been attending other courses now.
Yes.
So we want to say this is actually she said the instructions on how to to me. Maybe instructions, or if you explain to me, then I can choose in the form of instructions to make part of what I will say. Let me send the links to you so that these two things. And you will be here that day when I come, because I really want to start next week, Tuesday. Yes. Well, let's say, for instance, we are not around. What we have meeting here. So certainly by that 8 to 9 a.m. or Tuesday, somebody must be here. And for example, today I will say at the first step. Okay, once you know the schedule. So we're just comparing almost display. So and we have 15 that we so when I'm coming to teach, I will only come just with my lecture notes. Then I will sit down like this. Before we will be back. There. So your slide must have got to us. That's another problem. A day beforehand. And we have mounted it on the system. Because we do slides. Yeah. Slides. Yeah. Because in a day like this, we have several lectures. So we have mounted all of them. Now, those slides, will you be displaying it to the students, or they have it and they can harvest it? Or we see you as you are teaching. Yes, we'll see the slide. Okay. But I will not give them. I will give them. I will give them. Not give them. But even afterwards, go to YouTube, get the lecture, listen to it, over it, so that nobody has present. But when we drill the modules here, first the modules here, there is no way I can finish the module in one class or 1 hour. Okay. And I take the following week. When we got that lecture, I can't teach. Maybe I'll go and do a summary of the whole module. When you look at, when you teach for the first time, you will see that because we are about 17 or 18 that we teach the course, that we teach different topics. So it is very good for person to finish the topic on the day. Like so, whatever you're able to do, you can always send like the library course they are doing. 2 people. This one does 30 minutes, the other one does 30 minutes. Another week. So you have different. Everybody has to be involved. If they are not involved, they won't get things that are truths to them. So can you please send to me forwarded the thing so that it shifts so that I can now they are used to it, but at least we see the interface. But once lecture is not going, I will not see it. So that is supposed to be whether on their laptop problems. Okay, this link will be sent to all the students. So you forwarded to them. So when they of course. Okay. Okay. So once when it's time for that course, they just click. They click on this one. And they will be seeing me there. See them and saying just last. So when you give that attendance, by the time you get to 12, they consolidate attendance. But they can't submit until they are putting the 3 codes. It's not that somebody will get 1 code and run away and say that you must wait until you are putting 3 codes. Who said the codes now? It's you call it in the class as part of it. After 15 minutes, okay, take the first attendance code for today. Yes, all right. X, Y, Z, this and that. You will give me. I will give them. You will give me 16. Once I get your bill, the system will be sending on the morning of the lecture by 6:40. Attendance code that you drop for the lecture. And then okay.
So for that day that I will come, attendance will come.
Yes.
If another person comes, attendance.
No, now since you are the coordinator, since you are not, whether you are coming or not, the attendance code will be coming. And either my lecturer tomorrow, what's the test of take the attendance code for this month for your lecture to go. That is it. That was also that one very pay what of the attendance code of the school.
I should grab their slides.
Yeah, the slide.
But what we have now, because it's history.
Yes.
Because it's history.
Yeah.
Maybe I should go and tell them to do slides, but it may be difficult. What we have now is modules, like text.
Yes.
It's typed, it's everybody can see, but it's not in the form of a slides. As in
we should be able to
Microsoft.
We should be able to summarize the content.
And it's what we are doing is summary, not that it's not presented in the form of a slides. But let me experiment with it first on Tuesday. You now see, but I will tell my colleagues, whoever can do slides, do slides. But you cannot do slides, come with your notes. Type of note,
whatever it is, it must have been forwarded to us beforehand.
Yes, I will forward my own to you. Anyone can help me to do slides.
How do I have the time?
I will send my lecture
to find out the time to eat and still take my own lectures and still conduct research and still do every other.
Let's see how it goes.
We will.
Thank you very much for the training. The form of training, orientation. Cool. So it means that we come on Tuesday next week. Hello, sir. Hello, sir. Yes. It's because we couldn't finish our discussion in the morning now. We didn't, I think the whole thing ended abruptly. I said, let me call you back. That's why I decided to call. Sorry, we sponsor, if they want to do recording, the church will be able to help. But normally, for those who don't have the facility, we will see the qualify them and think of sending them to Lagos. And then the church can support and transport them. Also, we understood that in terms of students, amount is so high. So, want to bring keep them next to himself. But you must have seen the most question about this one is it's a project that it's just they will know because of course we have seen them because this is something pretty sure. Some states have some different product. One want body was the change himself was the state church. But this nobody can jump and just like the other time, nobody can jump and be meeting us directly without the recommendation, the selection of our masters. Sometimes you have something that's somebody's about master who have recommended that place and the state pastor here for that place, that kind of thing should not arise. To be done properly. The situation also where we have hotel that must do that near only you to have master directly children, but without the still cannot knowing about it giving stop those things. So that nobody, whether YPF or feels dependent on their own. I think we have talked about that for time. I think it's those people just continue to streamline things, especially to make our father and our mother very happy. So, well done, sir. What you like that? Once you know how to do that stage, is she studying music or is that a means of living? Oh, she's very good.
afterwards in your hands to see if somebody who is still reaching, somebody who can it's a vessel that any person becomes a vessel to this other they are exposed, where people will be calling them here and there. But even if they are calling you here and there, let the church, let's go be that. Okay. And just like the daily manna, it's just like the daily manna of today. When people want to expose, they forget their supervisors and other psychiatric parts to government. That know what makes some people to have left the church. Or they thought that they are okay, give us to wisdom. Thank you very much. Yes. All right.